In this video, I will be talking about gravitational force. We will see few important formulas as well. So the first formula is this one, and it is also called as a Newton's law of universal gravitation. So what this law is talking about is that the force between two masses, m1 and m2, which are separated by the distance r, is given by this formula. F is equal to g, which is gravitational constant. Remember that this g is not equal to small g, which stands for 9.8 meter per second square gravitational acceleration. So this g, capital G, is a gravitational constant, which is something different than the small g. So this is the universal law of gravitation, and based upon this law, we can also derive the formulae for gravitational force between Earth and other masses. So this first law of universal gravitation applies to any two masses in the universe. So it has nothing to do with Earth. Even if it is you are on Moon and there are two masses, this law applies. Or even if you are on different planet, this law will apply. Now, based upon this first law, we can work out the gravitational force due to Earth's gravity. So first formula in this range. So all these three formulas are related to the gravitational force due to the Earth. First formula is gravitational force on the mass m1, which is on the Earth's surface. Okay, and it is given by this formula g m1, capital M, it is the mass of Earth. Okay, and r square, so r here is the radius of Earth, because we are talking about this m1 mass which is on the Earth surface. That's why r over here is basically the distance between the center of Earth and that object, which is basically the radius of Earth. And we know that radius of Earth is not constant, so Earth is like an elliptical object. So at certain points, for example on North Pole and South Pole, the distance between the North Pole and the center of the Earth is lesser as compared to the distance between the center of the Earth and equators. So Earth is like this one, and if we have North Pole, South Pole, so you can see this distance, this is also radius r1 and this is r2. So you can see that r2 is greater than r1, and that's the reason the gravitational force is different on North Pole or South Pole as compared to these points. So that's about the Earth surface. Now next one is, if we have any object which is not on the surface of Earth but at some height, then that gravitational force will be given by this formula, say Fh, so force at certain height. Again, gravitational constant into m1, the mass that is at certain height. Then capital M is basically the mass of Earth. Then r plus h. Here r, let us have capital R over here and here as well. So r plus h. So r is basically the radius of Earth. Small h is the height from the Earth's surface where that object with mass m1 is located. So if you have this Earth like that and say object is over here, so basically this is the radius r and this is the h. So basically this particular distance is the total distance between that object and the center of the Earth. And finally we have got gravitational force at specific depth in the Earth. So for example, let us say we have got this Earth and this is the center, and we have got some point over here which is inside the Earth. So if you want to find out the force between these 2 points, we have got this formula, the last formula. Again, gravitational constant g into, let us say that object's mass is m1, into capital M, that is Earth's mass, okay, divided by r cube. Okay, so here you can notice that it is r square in both these formulas, but over here we have got r cube. The reason why we have here r cube is because when we go deep into the earth, the mass is changing, okay, and mass of the sphere is directly proportional to the cube of the radius, and that's why we have got r cube over here. So this formula is a little bit different from other formulas, and also we have to multiply this by the small r. So small r is basically the distance between the particle and center of the earth. So last formula is a little bit different, but all these most of these formulas have been derived from the Newton's law of universal gravitation. This one. So it's very, very important law. Thank you.